Hello class, and welcome to Intermediate Algebra, or Math 0314, a course designed to help you prepare to get into college algebra later in the semester. I'm Mr. Lee. You probably won't be seeing much of my face on the videos, but you will be seeing quite a bit of my hand and writing. So where this class starts is some relatively easy stuff, but stuff you've possibly seen before, but stuff that's extremely critical for algebra. So we're going to start with linear equations. Now, some guidelines to solving equations in general is if you've got fractions or decimals, you multiply by a common denominator to clear a fraction, or you can multiply by 10 or 100 or 1,000 multiples of 10 to clear decimals. Simplify each side by removing parentheses and combining like terms, add or subtract, and then divide or multiply to get your variable by itself. Now, some terms that you need to know. Conditional means it's true for one number only. That's your normal solution. So that's when you solve for x, you get like x equals 2. Identity is when something is always true. So that means when you solve for x, what usually happens is all of your variables cancel out. For example, you have 2x on one side and 2x on the other side, and when you subtract them, all of your x's are gone. So you end up with something like 0 equals 0, and 0 is always equal to 0, so every number is a solution. And a contradiction is when your answer is never true. So that's the same situation as identity, where all of your variables cancel out, but instead of 0 equals 0, you may end up with like 5 equals 2. And when is 5 equal to 2? Never. So let's just go through a few examples here. 7x minus 5x plus 15 equals x plus 8. We have no fractions, we have no parentheses, but we do need to combine like terms. 7x minus 5x is 2x plus 15 equals x plus 8. Both of my sides are simplified, so now it's about getting my variable to one side and my numbers to the other side. Subtract x to x plus 15 equals 8, and then subtract the 15. So x equals negative 7. This is what we would call a conditional answer because we got x equals a specific number. Now looking at number 2, we've got parentheses. Now in order to deal with parentheses, we have to distribute this negative 5. So we have a negative 5m. Negative 5 times negative 1 is plus 5. On the other side, we have negative 5m. Distribute the negative, so minus 2m. Minus negative 4 is really plus 4. Plus 5. So combining our m terms, negative 3m, negative 5m makes negative 8m. 6 plus 5 is 11. Negative 5 minus 2 is negative 7m plus 9. Move all of my m's to one side, so plus 7m. Negative 8 plus 7 is negative 1m, or just negative m. Subtract the 11 to the other side. I'm going to do this all in one step, but you can do it in two if you'd like. 9 minus 11 is negative 2. Now we have to divide both sides by negative 1, or multiply both sides by negative 1. We get m equals 2. Now what you can always do in this situation is plug it back in to see what happens. When m is 2, negative 3 times 2 is negative 6, so these two will cancel. And then 2 minus 1 is 1, so negative 5 times 1 is negative 5. So on the left side, we've got negative 5. On the right side, 2 times 2 is 4, minus 4 is 0, so this is gone. Negative 5 times 2 is negative 10, plus 5 is negative 5, so we get negative 5 on both sides, so they are equal. Now let's see what this looks like with possibly some fractions or decimals. Okay, solve each equation and check your solution if you'd like. 3/4 x minus 1/3 x equals 5/6x minus 5. So I need to multiply by something that will get rid of my denominator. There are a few options here. Some people will just multiply by all of the numbers to clear the denominator, but remember, anything you multiply by, you have to multiply everything by. So it might be easier to look at number 4 first and come back to number 3. What's a number that will cancel out a 6 if I multiply by it? Well, a 6. Will a 6 also cancel out a 3? That's the question. Yes, because it's a multiple of 3. So this 6 gets distributed to everything if you multiply it, even if something didn't have a fraction. So we have 6 times 4t plus 1 over 3 equals 6 times t plus 5 over 6 plus 6 times t minus 3 over 6. 6 divided by 3 is 2. So they reduce to 2, but the 4t plus 1 is still there. 6 divided by 6 is just 1, so they cancel or reduce. 6 divided by 6 again, so plus the t minus 3 from here. We're going to distribute the 2, so we get 8t plus 2 equals, combine our like terms, 2t. Looks like 5 minus 3 is plus 2. Subtract the 2t and the 2. 8t minus 6t, or 8t minus 2t, excuse me, is 6t. 2 minus 2 is 0. When I divide by 6, 0 divided by anything else, as a reminder, is 0. T equals 0. Now how does that change over here? Well, there's not one of these denominators that's going to clear the other. Yeah, the 6 will clear the 3, but it won't clear the 4. So I really need to multiply what we call about the common denominator. So the common denominator between 4, 3, and 6 is the smallest number that all of these go into. In that case, this is 12. 4 goes into 12, 3 goes into 12, 6 goes into 12. So I need to multiply all of these by 12, including the minus 5. Even though it's not a fraction by looks, it's really a minus 5 over 1. And anything you do to part of the equation, you have to do to all of it. So we get 12 times 3/4 x minus 12 times 1/3 x equals 12 times 5/6 x minus 12 times 5. Twelve divided by 4 is 3. 3 times 3x is 9x. 1/3 of 12 is 4, so minus 4x. 12 divided by 6 is 2. 2 times 5 is 10. 10x. 12 times 5 is 60. So 9x minus 4x when we combine is 5x equals 10x minus 60. Subtract the 10x over to get negative 5x equals negative 60. And when you divide by negative 5, the negatives will cancel. You get x equals 60 over 5. So x is 12. And you can plug it back in and check. We're not going to. Okay, and lastly, number 5, 0.09k plus 0.13 times k plus 300 equals 61. My suggestion to you is possibly to distribute first. So we get 0.09k, distribute the 0.13 plus 0.13k. You may have to multiply this out on the right. I will tell you that 0.13 times 300 is plus 39 equals 61. I'm going to combine my two 0.09k plus 0.13k is 0.22k and move my 31 to the other side, or 39 to the other side by subtracting. So this equals 22. In order to clear decimals, you need to count how many decimal places are to the right of your decimal that you want to get rid of, and that's how many zeros you need after a 1. So there's 2 decimal places, so I need to multiply by 100. That'll move my decimal place 2 to the right, and that'll just add 2 zeros on the other side if there's a whole number. And then divide by 22, get k equals 100. 6 and 7 are exactly the same as your previous problems. They just want you to state at the end conditional, identity, or contradiction. And that's all for 2.3.